The next few slides are about output rate limiting and the output clause. The output clause is optional. The output clause controls or stabilizes the rate at which events are output. The output clause can also suppress output events. Use the output clause when output is regular and not triggered based on some condition. Use contexts instead when output is triggered or suppressed by an event, or time or another set of conditions. Contexts are discussed later. The syntax for the output clause is the output keyword. Optionally, the after keyword and then either a time period or a number and the events keyword. Then, optionally, one of the control keywords, all, or first, or last, or snapshot. Then the every keyword. Then either a time period or a number and the events keyword. The above syntax isn't complete. We'll discuss the when-terminated keywords later when we discuss contexts. We don't discuss the output by cron tab and expression options here. The after keyword suppresses output until the time period has passed or a number of events have occurred. The all and the first and the last keyword are only relevant when the query has a group by clause. They control output per group. The snapshot keyword requires a data window and outputs according to the data window events. When no keyword is provided, the output is all output events that accumulated since the last output. Without the output clause, a query produces results according to the from clause. For instance, a query that outputs for each incoming event is. This sample query outputs the user and the current count per user when a logout event arrives. Select user ID, count star. From logout event. Group by user ID. Add output last to the query to output only the last values per group that it changes since the last output. For instance, a query that outputs every 1 minute is. This query outputs the user and the last count per user every 1 minute. It outputs only those groups that it changes. Select user ID, count star. From logout event. Group by user ID. Output last every 1 minute. Add output first to the query to output only the first values per group that it changes since the last output. For instance, this query outputs the first user and the count per user, considering the last 1 minute of logout event events, but only when the count is greater than 10. This query won't output for the same user for 10 seconds thereafter. Select user ID, count star. From logout event. At time parenthesis 1 minute. Group by user ID. Having count star greater 10. Output first every 10 seconds. Add output all to the query to output all groups, regardless of whether the group had changes or not. For instance, this query outputs all users and the count per user every 10 seconds, regardless of whether the user had changes or not, considering the last 1 minute of logout event events. Select user ID, count star. From logout event. At time parenthesis 1 minute. Group by user ID. Output all every 10 seconds. This slide and the next couple of slides are about joins. A join has a from clause that has multiple entries. The from clause may have any combination of the following entries. The from clause can have an event type with optional filter condition expressions and data windows. For example, withdrawal. Parenthesis amount greater 400. At time parenthesis 10. The from clause can list named windows or tables. For example, large withdrawals window, parenthesis account ID in quotes 1, quotes 2. Assuming that large withdrawals window is a named window. The from clause can have patterns. For example, pattern, square brackets, every LE equals login event, followed by logout event parenthesis user ID equals LE.user ID. The from clause can have SQL and method invocations. For example, SQL, my customer, square brackets, quote select name from customer. For example, method, call my service, empty parenthesis. Fire and forget queries can join, but allow only named windows, tables and SQL in the from clause. Joins are good for detecting situations where constitute events arrive in any order. Joins are good for finding patterns that are one-to-many or many-to-many. The order of items in the from clause is not relevant. Joins can be iterated by the iterator programming interfaces. The runtime returns the join results according to data window contents. The EPL compiler performs query planning and considers the following. The compiler considers the where clause, if present. The compiler considers the on clause, if present, which is generally used with outer joins. Not to be confused with the on clause of on action statements. The compiler considers existing indexes as defined with create index, applicable only to named windows and tables. The compiler considers unique data windows, if present in the from clause. The runtime uses existing indexes or builds and maintains new indexes according to the query plan. Turn on query plan logging to see the query plan. The at hand annotation provides query planning hints to the query planner. The default join is the inner join. Does not have a join keyword. The inner join's result is an intersection, while an outer join's result is a union. So, for an inner join, if any of the from clause entries match no rows, the output is no rows. To illustrate, this statement is an inner join considering the last 10 seconds of events. Select star from withdrawal at time parenthesis 10 as W, comma, settlement at time parenthesis 10 as S, where S.account ID equals W.account ID. When a withdrawal event arrives, the runtime finds settlement events with a matching account ID, and outputs a row for each settlement event it finds. When a settlement event arrives, the runtime finds withdrawal events with a matching account ID, and outputs a row for each withdrawal event it finds. Each output row has two columns, the W column has the withdrawal event and the S column has the settlement event. This sample query joins three streams. Select star from login at time parenthesis 1 minute as S1, comma, page visit at time parenthesis 1 minute as S2, comma, logout at time parenthesis 1 minute as S3, where S1.userID equals S2.userID and S1.userID equals S3.userID. When a login event arrives, the runtime looks up page visit events with a matching user ID. If it does not find any page visit event, it is done and the output is no rows. If it does find page visit events, the runtime then looks up logout events. If it does not find any logout events, it is done and the output is no rows. If it does find logout events, the output is all combinations of page visit events and logout events, a Cartesian product. When a page visit event arrives, the runtime looks up login and logout events, similar to above. When a logout event arrives, the runtime looks up login and page visit events, similar to above. The unidirectional keyword identifies streams that provide the events that execute the join. If the keyword is present for a stream, all other streams in the from clause become passive streams, meaning they do not generate join results. For instance, this join is only triggered by withdrawal events and not by settlement events. Select w.account_id as account ID, w.amount as amount, s.settledate as date. From withdrawal as w unidirectional, settlement at time (10) as s, where s.account_id equals w.account_id. When a withdrawal event arrives, the runtime finds settlement events with a matching account ID, and outputs a row for each settlement event it finds. When a settlement event arrives, there is no output. A from clause entry that has the unidirectional keyword cannot also have a data window, since there is no need to retain events. Joins require that any entries in the from clause that are an event type must have a data window or must have the unidirectional keyword. Since without a data window, a join wouldn't be able to find rows. The following query is not valid. This is an invalid query. The logout event is not a named window and does not declare a data window. When a login event arrives, there would be no logout event since there is no data window. Option 1 is to add a data window. Correct query 1. Now logout event has a data window. Select star from logout event at last event, login event at last event. Option 2 defines as unidirectional. Correct query 2. Now logout event is unidirectional. Select star from logout event unidirectional, login event at last event. An outer join is a union, and unmatched rows can be output from all entries in the from clause. As compared to an inner join, which does not output any rows when there are no matches. There are a few types of outer joins. Left outer join returns only unmatched rows from the left entry. Right outer join returns only unmatched rows from the right entry. Full outer join returns unmatched rows from the left and right entry. The on keyword identifies which columns in each entry in the from clause to link and can be used with all types of joins. For instance, this query outputs the last login event per user and the page visit events of the last 10 seconds for the same user. Select star from login at unique user ID as login. Full outer join page visit at time (10) as page visit on login.user ID equals page visit.user ID. When a login event arrives, the runtime looks up page visit events for the same user. If the runtime does not find any page visit events, it outputs a row that is columns login as the login event and page visit as null. If the runtime does find page visit events, it outputs a row per page visit event that is login as the login event and page visit as the page visit event. When a page visit event arrives, the runtime looks up login events for the same user. The output is similar to above with login as null when not found. The next couple of slides discuss SQL in the from clause. The from clause can have a SQL query. A SQL query in the from clause does not trigger the join to execute. A SQL query in the from clause is typically used in a join or outer join. The runtime executes the SQL query, or queries a cache, when the join executes. The syntax of the from clause entry is the SQL keyword, database name, square brackets, double quotes SQL text. The SQL text is a string within square brackets. A SQL query in the from clause requires adding the following to the configuration object. Configure a database name and a JDBC driver or data source. Optionally, configure a cache policy, such as least recently used or expiry time. The runtime can retrieve results from cache instead of making a database call for every event. The SQL text can have parameters. The parameter syntax is curly braces, parameter expression. The parameter expression can be event properties of other entries in the from clause. At compilation time, the compiler does this. The compiler validates the SQL query and its parameters. The compiler obtains the name and type information for columns in the SQL text select clause. The compiler performs query planning to determine the order of join execution, taking parameter expressions into account. The compiler performs query planning to determine whether to build an index based on the EPL where clause, not the SQL where clause. If a cache is configured, the runtime caches this index the same as it caches SQL query results. This example assumes the following. The configuration has a relational database named myCustomerDB. The relational database has a table named customer in the columns as cct_id and cust_name. This query returns the withdrawal customer name for the account. The customer name comes from a relational database. Select account ID, customer name, from withdrawal, as W, SQL:myCustomerDB, square brackets, double quotes. Select cust_name, as customer name, from customer, where ACCT_ID equals $, curly braces, W.account ID. Here, the withdrawal event's account ID is a parameter to the SQL query. If the configuration does not configure a cache, when a withdrawal event arrives, the runtime executes the SQL query. If the configuration does configure a cache, the runtime first checks the cache for the row by account ID. If the cache has no row, it executes the SQL query and adds the row to the cache by account ID. This example puts the where clause into EPL instead of the SQL text. The select clause and the from clause is the same as in the last example, but this query has the where clause as follows. Where cdb.accct_id equals W.account ID. If the configuration does configure a cache, the runtime first checks the cache for the row by account ID. If the cache has no row, it executes the SQL query and adds all rows that the SQL query returns to the cache, indexed by account ID. Since this SQL query returns the whole customer table, for performance reasons, the configuration should probably configure a cache, depending on the number of rows in the table. This slide and the next few slides discuss method in the from clause. Putting a method in the from clause is very similar to SQL in the from clause as outlined in the previous slides, but instead calls an application-provided method rather than SQL. The from clause can have a method call. Putting a method in the from clause does not trigger the join to execute and is typically used in a join or outer join. The runtime calls the method, or queries a cache, when the join executes. The syntax of the from clause entry is method, colon, method name, parenthesis method parameters. Putting a method in the from clause requires adding the method name, method target and cache settings to the configuration object. The application provides type information for the events returned by the method. Note: use single-row functions for lookups instead, when a join is not needed. Joins are good for outputting combinations of rows. The parameter expressions can be expressions containing event properties of other entries in the from clause. At compilation time, the compiler does this. The compiler validates the application-provided method name, footprint and method parameters. The compiler obtains the name and type information of events returned by the method. The compiler performs query planning to determine the order of join execution, taking parameter expressions into account. The compiler performs query planning to determine whether to build an index based on the EPL where clause. If a cache is configured, the runtime caches this index the same as it caches method invocation results. This example assumes the following. The configuration contains information about a from clause method by name my customer profile. The application provided method takes an account ID as a parameter and returns a customer name. See the documentation for how to set up a from clause method. This query is a join of withdrawal events with customer profile information. The join calls an application provided method which may return multiple rows. Select account ID, customer name from withdrawal as W, method my customer profile parenthesis w.account ID. If the configuration does not configure a cache, when a withdrawal event arrives, the runtime calls the method. If the configuration does configure a cache, the runtime first checks the cache for the row by account ID. If the cache has no row, it calls the method and adds the row to the cache by account ID.